Hello everyone, welcome to our channel Amazing World of Science, and this is Dr. Radha Subramaniam, your science teacher. I had already uploaded the first lesson from class 9 yesterday, and if you remember, you had learned about the different states of matter and so many concepts we had learned yesterday. So today we will be continuing with the, I'll just refresh the gaseous state we had learned yesterday. Like we had learned that when your mother cooks something in the kitchen, and even without you going inside the kitchen, from the smell itself you can know that what is being cooked. And how does the smell reach you? Because the particles of the food smell, it mixes with the air spread from the kitchen, and it reaches even if you are far away within seconds, because the rate of diffusion for gases when you compare with solids and liquid is great. And with high speed, due to high speed of particles and large space between them, gases show the property of diffusing very fast into other gases. And I already had taught you about diffusion in our yesterday's class. And in gaseous state, particles move randomly. Randomly means here and there with high speed. And because of this high speed, see, some students are playing, running in the playground. If you run too fast, you will hit each other. Similarly, the particles will hit each other and also with the walls of the container. And because of that, we say that the gases exert a force or pressure per unit area on the walls of the container. So you can see here the magnified pictures of the three states, that is solid. See, it's well arranged, see the particles. And here in liquid, somewhat, and it takes the shape of the container. And also see gas, this is a balloon, they are randomly arranged. Okay. And as I told you all already, we will be uploading lessons from classes 8, 9 and 10, and also I will be explaining the exercise questions so that you get a good foundation. Okay, now today we will learn about this concept 1.4 topic, can matter change its state? You know that if you look at water can exist in three states of matter. What are they? First is solid. How does water exist in solid form? It exists as ice. Then in liquid form is, you are familiar, you know that water, you drink water at home. What is it? It's the liquid form. And gas form as water vapors. Even you boil something or heat water and all that, you can see smoke, fumes coming from it. That is called water vapor. Okay, now what happens inside the matter? What happens during change of states, and how does this change of state happens? For knowing all this, now we will go into another concept. See, when you increase the temperature of solids, see, take some ice or metal or just heat some solid, what happens is that the kinetic energy of the particles in the solid also will increase once the temperature rises. So when the kinetic energy, what is meant by kinetic energy? The capacity of a body to move. Okay, the energy acquired by a body due to its movement is called kinetic energy. So when it starts moving fast, or when you increase the kinetic energy, the particles will start vibrating, shaking at great speed. Okay, so at that time the energy which you are giving to the solid by heating, that will overcome the force of attraction between the particles. Okay, so because of that, the particles will leave their position and they will start moving about freely. And at a particular stage, when when the energy or when the force of heat energy is more, when you supply more heat energy from outside, a stage is reached when solid will melt and then it is converted into liquid. This is how change of state happens. That is, how can you change a solid into liquid? By heating it or by supplying temperature. Now the temperature at which a solid melts to become a liquid at the atmospheric pressure, we call it its melting point. Okay. So what does the melting point of a solid indicate? The strength of the force of attraction between the particle. If the strength of the force of attraction between the particles is more, you have to supply more temperature. Okay, see the melting point of ice is 273.16. The process of melting, that is changing of solid into liquid, that we call by another name which is known as fusion. So what happens when solid melts? Temperature will be the same. So you are providing some heat, isn't it? Where will it go? That is, during melting, temperature of the system will not change once the melting point is reached, but still the ice will keep on melting. Why? What happens? Because even though we continue to heat the vapor, heat the beaker, and by supplying heat, so that heat will be used up in changing state by overcoming the force of attraction between the particles. So this heat energy is absorbed by ice, and even though it is absorbed by ice, it doesn't show any rise in temperature. So what do we think? That the heat energy is hidden into the contents of the beaker. Okay, this is the beaker where we are heating the substance, and there the heat energy is hidden, and that we call it as latent heat. So word latent heat means hidden. So the amount of heat energy which is required to change 1 kilogram of solid into liquid at atmospheric pressure at its melting point is known as latent heat of fusion. This is very important definition. You must know this definition by heart. So particles in water at 0 degrees Celsius. What is meant by 0 degrees Celsius? It is 273 Kelvin. They have more energy compared to particles in ice at the same temperature. So remember, this concept is very important. Now what happens when you supply heat energy to water? Particles will start moving faster. Okay, at a certain temperature or a point is reached when particles get enough energy to break free from the force of attraction of each other. So they are all holding to each other. Okay, so when force from outside comes that is strong enough to break the particles, what will happen? Liquid charge changes into gas. So the temperature at which a liquid starts boiling at atmospheric pressure is called boiling point, and particles from the bulk liquid gained through energy will change into vapor. That is, the liquid will change into vapor state once you start boiling the liquid. Okay, so for water this is 373 Kelvin. That is, water boils at how many degrees Celsius? 100 degrees Celsius. When you convert 100 degrees Celsius, you just add 273 plus 100. That is 373 Kelvin. Okay, now you must know to define latent heat of vaporization. Okay, so what is latent heat of vaporization? You have to learn the definition. Water vapor at 373 Kelvin or 100 degrees Celsius, they have more energy than water at the same temperature. That is an important concept, and this definition you can do it in the same way you define the latent heat of fusion. Everything the definition is same. Okay, so just the liquid into gas or solid into liquid, that alone will change. And the particles in steam, they absorb the extra energy in the form of latent heat of vaporization. Now you understand that when you heat solid, it changes into liquid, heat liquid changes into gas, then cooled gas comes back to liquid, cooled liquid goes back to solid. So we know that matter can be changed into another state by just changing the temperature, and also you know that the substances around you can change from solid to liquid and liquid to gas on applying heat. Okay, just remember that. Now here a change of state happens directly from solid to gas without coming into the liquid state, or vice versa. Vice versa means what? Just the opposite. That is what we call sublimation. Remember what is sublimation? Change of state directly from solid to gas. Now effect of change of pressure. What happens when you start putting pressure? In gas cylinder and all that, the gas is highly compressed and enclosed in a small cylinder. So what happens is that when the particles come close, what will happen? See, applying pressure and reducing temperature, you can change gas into liquid form, and then that can be enclosed or taken in a vessel. I think you might have heard of solid carbon dioxide. That is carbon dioxide in the solid form. It is stored under high pressure. Okay, and some carbon dioxide gets converted directly to gas on decrease in pressure to 1 atmosphere. It is without coming into liquid state. That is why solid carbon dioxide is also known as dry ice. So what do you understand from this? Pressure and temperature, it is what that fixes the state of a substance, whatever it is, solid or liquid or whatever it is. So these are all, see this chart, solid, fuse, when you undergoes fusion to become liquid, vaporizes to become gas, gas condenses to become liquid, and sublimation becomes solid. So in this conversion of all these state into solid, sublimation becomes gas. So conversion of each other. Okay, now evaporation. So what is evaporation? Just nothing. You can see in day-to-day life, change of state from liquid to vapor, without reaching the boiling point. That is, if you keep water without covering it, slowly water changes into vapor. And also wet clothes dry up. Okay, what happens to the water in these two cases? See, the particles of matter are always in state of movement and they never rest. And at given temperature, in any gas, liquid or solid, whatever it is, the particles with different amount of kinetic energy. In the case of liquid, small fraction of particles, at the surface, they have higher kinetic energy. So what happens, they will try to escape from the surface of the water. Okay, and they break away from the force of attraction, and that is how they get converted into vapor. So because of that, the phenomena of change of liquid into vapors or at any temperature below its boiling point, that is what we call as evaporation. That is, before reaching the boiling point, because of the high amount of kinetic energy, they escape or break the force of attraction. That is known as evaporation. Because of that only wet clothes dry and these phenomena occur. Now, what are the factors which affects evaporation? Okay, there are a few factors. First one is, when you increase the surface area, then the evaporation rate will increase. See, always when you fold the clothes and hang, it won't dry fastly, but when you spread and hang them, they will immediately evaporate and the water content will go, so drying the clothes. And you can increase the temperature, more number of particles will get kinetic energy to change into vapor state. And the humidity decreases, decrease in humidity. What is humidity? It is the amount of water vapor, how much water vapor is present in the air. So the air around us cannot hold more than definite amount of water vapor at a given temperature. Suppose if the amount of water in air is already high, then the rate of evaporation will decrease. Remember this point. Then increase in wind speed. On a windy day, the clothes will dry faster, because when the wind increases the speed, the particles of water vapor will move away with the wind and the clothes will dry fast. And evaporation also can cause cooling. Suppose in an open vessel, the liquid keeps on evaporating, and what happens is that the liquid particles will absorb energy from the surroundings again to maintain the energy loss during the evaporation. So because of this phenomena, absorption of energy from the surrounding, the surface becomes cold. And here what happens when you pour some nail polish, the particles will gain energy from your palm or the surroundings and evaporate. Due to evaporation, it causes cooling effect. And after a hot sunny day, people will pour water on the roof or open ground, because of the latent heat of vaporization of water will help to cool the hot surface. So all these phenomena are examples of this. So you wear cotton clothes in summer. Why? Because the body will perspire more, and during evaporation, the particles at the surface of the liquid will gain energy from outside or the body surface, and they will change into vapor. And because to make up for the lost energy, and this energy which is equal to the latent heat, vaporization, that is absorbed from the body. Because of that, the body will be cool. And cotton is a very good absorber of water, so that will help in exposing it to the atmosphere for easy evaporation. So, these points to remember, it's very important. You have to go through all these points before your exams, and the lesson itself is given in a brief summary over here. So I hope this first lesson is clear to you. We have come to an end of the lesson, and do like, share and subscribe to our channel, Amazing World of Science, and please share with your friends, and we'll be soon uploading next video. So till then, thanks for watching.